Today we're starting graphs of motion. We're going to learn how to plot and interpret graphs. Okay? इस class के end में you guys will know how to deduce information about motion from different shapes of graphs. हम लोग दो types of graphs करेंगे. We will be doing displacement time graphs and velocity time graphs. Let's look at displacement time graphs first. If a body is covering a distance or length from A to B, तो उसकी जो total length है, we call that distance. Or shortest length between 2 points is known as the displacement. जब भी body straight line motion में होगी, like it's traveling on a road that is straight, इस situation में हमारे पास distance is equals to displacement. Now, here we're going to do displacement time graphs. Let's look at the first type. And these graphs should be very repetitive. Paper में इसके बहुत ज़्यादा questions आते हैं, इसलिए I would like really appreciate if you guys would listen to me very carefully. अच्छा, first graph में हमारे पास है कि you guys can see that the displacement, it's the same. Even though the time is increasing, but the displacement remains the same. There's no change in displacement. Time बढ़ता जा रहा है, लेकिन आपकी displacement constant है. और ऐसा कब होता है? When the body is stationary or when the object is at rest. And let's look at the gradient concept. Displacement time graphs gradient gives us the velocity. If you guys remember the formula for gradient का क्या formula होता है? Rise over run? What is the rise? It is the change in the y value. And what is run? It's change in the value at the x-axis. हमारे पास y-axis पे क्या है? Displacement. और x-axis पे क्या है? Time. We use the letter small s for displacement. And what is displacement divided by time equals to? Velocity. So the gradient of displacement time graph gives us the velocity. Now let's look at another type of shape. Let's see a graph that is passing through the origin. Whenever you have a graph passing through the origin, it means that it's a linear graph. Okay? So you guys see the यहाँ पर displacement linearly increase कर रही है. What does linear mean? That it increases in accordance with time. It's directly proportional to time. जैसे जैसे time increase कर रहा है, displacement भी वैसे ही increase कर रही है. So if I have to figure out the velocity from this graph, I will look at the gradient. इसका gradient क्या show कर रहा है? जब भी आपके पास straight line हो and it's passing through the origin, gradient is constant. Okay? Constant gradient का क्या मतलब है? Velocity क्या होगी? See कि gradient जो है वो velocity के equal होता है. ठीक है? क्योंकि the y value, which is displacement divided by time, is equals to velocity. Constant जो graph होता है, a straight line that is passing through the origin has a constant gradient. अगर gradient constant होता है, तो हमारे पास velocity will all be constant. And another term that we use for constant velocity is uniform velocity. Constant or uniform. यहाँ पे हमने discuss कर लिया when an object is at rest and when it's undergoing uniform velocity. Let's see what happens when the velocity is changing. Now we're going to discuss the examples for non-uniform velocity. Non-uniform velocity graphs, या फिर कोई भी जब किसी भी non-uniform quantity के graphs show करने हो, तो we have curves and not straight lines. Let's look at the first curve. That is something like this. Whenever you guys have an upward facing curve, it means that the velocity is increasing. And whenever you will have a downwards facing curve, that means your velocity is decreasing. ठीक है? कैसे पता चला हमें? कि हमें पता है कि displacement time graph का gradient is equals to velocity. Or upward facing curve का gradient is increasing. And how can we figure that out? Curves, whenever you have a curve given, and even in the question you might be tested, कि वो आपको curve graph दे दें and they say कि इस instant पर tell us the velocity of that moving body. How will you figure out the velocity from the curved diagram? What you do is that you draw a tangent. What is a tangent? इस point पर आप एक straight line draw करते हो. And then when you have a straight line, you can surely figure out the gradient. And how is that? I'll even elaborate that a bit. You draw a triangle, you complete this right angled triangle, and then you use your formula of rise over run.
There is actually another formula. Can we use that over here? The one y2 minus y1 divided by x2 minus x1?
Yes, that is also perfectly fine. Like, it's different names for the same formula. You see, rise is simply the change in y. That is y2 minus y1. And run is simply the change in x. That is x2 minus x1. So Nabiha, your formula is perfectly right. You can use this as well. Y2 minus y1 divided by x2 minus x1. The only reason I didn't bring this up was to, not make it seem like things are complicated for those who might not be familiar with this one. So you can definitely use this formula. तो फिर आप क्या करोगे? You will mark this as your y2, this as your y1. And how is that so? You will extend the lines to the y-axis to figure out the change in y. As for the x, you will mark this as x2 and this one right here as x1. This is your x2 and this is x1. And you subtract these two to find out the change in your x value. So is it clear, guys, how we can figure out the gradient from a curve?
Yes, miss, thank you.
You're welcome. So the simple concept, I'll just summarize it. जब भी आपके पास एक curved graph हो और question में आपको पूछा जाए कि इसकी velocity increase हो रही है या decrease. So you guys are going to look at the shape of the graph. अगर upward facing graph होगा, upward facing curve होगा, तो the velocity is increasing. अगर downward facing curve होगा, तो velocity is decreasing. Upward facing में, let me write it here. Velocity is increasing. Downward facing curve में velocity is decreasing. अगर आपसे वो किसी भी एक instant पर पूछ लें कि velocity क्या है, तो आप उस जगह पे एक dot लगाओ and then draw a straight line at that instant. And then draw a right angle triangle if you need to. If you don't need to, that's also okay. And figure out your gradient. आपका gradient will be equal to the velocity. Let me draw tangents. इस straight line को जो हम instant पे बनाते हैं tangent कहते हैं. I'll draw tangents and I'll see कि gradient क्या हो रहा है. This is my first tangent. इस instant पे बना लेती हूँ. इस instant पे, at this instant, and I'll draw a tangent at this instant. This is just to check कि gradient के साथ असल में क्या हो रहा है. I have a tangent here, a tangent here, and a tangent over here. Now I'll bring all of my tangents downwards to prove my point. You guys see कि over time, जैसे जैसे graph upward curve किया है, ये हमारा steep होता जा रहा है, right? It's becoming closer to the vertical. So the more steep a graph is, the greater the gradient is. क्योंकि हमारे tangents की steepness या slope बढ़ती जा रही है, we can definitely confidently say that the gradient is increasing. And if the gradient is increasing, the velocity is increasing. Displacement time graph हमारे पास क्या show करता है? Velocity. Gradient of displacement time graph is velocity. I want you guys to repeat it to yourselves 2 to 3 times. Okay, the gradient of displacement time graph is velocity. जब हमारे पास curved graph हो, gradient कैसे find करते हैं? We draw tangents. Different points ले लो. And at that point, and at all of those points, draw straight lines. These are called tangents. Now you see your tangents are becoming less steep. ये वाला steep है, or at the end it's closer to the horizontal. इसकी steepness कितनी कम हो चुकी है? क्योंकि इसकी steepness reduce हो रही है, we can prove that the gradient is decreasing. Gradient is decreasing. But अगर gradient decrease कर रहा है, the velocity will automatically be decreasing because the gradient of displacement time graph is equals to velocity. Is this clear, guys?
Yes, miss.
Okay. Now I will be asking questions from you guys randomly from what we have learned. Husnain, can you please tell me कि uniform velocity के लिए हमारा graph straight line होता है या फिर is it a curve?
Straight line.
That is correct. Non-uniform velocity के लिए हमारा graph किस shape में होता है? Haya, could you please tell me?
I'm not sure. Yes, sir.
Okay.
I'm not sure,
Non-uniform. Uniform velocity के लिए graph is a straight line passing through the origin.
Straight,
Or
yes.
non-uniform. Just let's look at this. Uniform velocity के लिए it's a straight line passing through the origin. Or non-uniform velocity यानी कि changing velocity के लिए it's a curve. Nabiha, could you please tell me increasing velocity के लिए what is the shape of the graph? Is it a downward facing curve or an upward facing curve?
It's a dominant phase.
Is it
Okay.
it's upward?
Yes, I know it's a little confusing. Don't worry, अगर आपको पहली बार में ये सब याद नहीं हो रहा, it's really okay. Just memorize कि upward facing curve is increasing velocity and downward facing curve is decreasing velocity. Up is increase, down is decrease. Okay? An upward smiling face is increasing velocity and a downward face is a decreasing velocity. I will summarize this for the last time before we move on to the next topic. And these graphs will stay the same for velocity time graph. इसलिए अगर आपको ये याद हो जाता है ना, तो आपको velocity time graphs automatically याद हो जाते हैं. When you have a straight line that is passing through the origin, let me remove the extra information ताकि आप लोग confused नहीं हो इसमें. When you have a straight line passing through the origin, तो हमारे पास velocity जो है वो constant है. और constant velocity को हम कहते हैं uniform velocity. ठीक है? अगर हमारे पास curved graph हो, तो उसमें होती है non-uniform velocity यानी कि changing velocity curves में. अगर हमारे पास upward facing curve है, तो increasing velocity, downward facing curve है, तो decreasing velocity. Is it better now?
Yes, miss.
Yes, miss.
Okay, great. All right, let's look at velocity time graphs now. These are also the same as displacement time graphs. बस इनमें इतना सा फर्क है कि velocity time graph का gradient gives us the acceleration. ठीक है? जैसे हमने ऊपर displacement time graph का gradient के लिए कहा था, it gives velocity. Velocity time graphs का gradient हमें बताता है acceleration. क्योंकि velocity divided by time is equals to acceleration. ठीक है? Now let's look at the first type of graph. Let's say I have just a minute, 1, 2, 3, 4, 5, and 6. Okay. Let's say I have a line at this point. Husnain, इस ग्राफ में velocity क्या है? Y axis हमारा velocity represent कर रहा है, तो आप मुझे बता सकते हैं कि इस ग्राफ में velocity क्या है? अच्छा, हमारा
0.
Y axis, that is correct, excellent job, it's 0. हमारा Y axis, it's giving us the velocity, और हमारा ग्राफ कहाँ पर plot हुआ है? 0 पर. Here we say that the velocity is 0. Time गुजरता जा रहा है, लेकिन velocity हमारी 0 है, यानी कि body यहाँ पर rest पर है. जब वेलोसिटी 0 हो, जब आप बैठे होते हो, आपकी स्पीड इंक्रीज नहीं हो रही होती, वेलोसिटी 0 है तो आप रेस्ट पर होते हो ना, तो that's why we say that here the velocity is equals to 0. अगर वेलोसिटी 0 है तो gradient or acceleration is also equals to 0. How is that so? हमारे पास horizontal lines का gradient is equals to 0. Do you guys know that? Horizontal lines of gradient is equals to 0. And why is that so? Because there is no change in velocity. I'll just elaborate that a bit. हमारी velocity constantly 0 जा रही है, उसमें कोई change नहीं आ रहा, और acceleration हमारे पास क्या होता था? Change in velocity divided by time or change in time. अगर velocity में change ही नहीं आ रहा, change in velocity 0 है, तो 0 divided by whatever number will always be equals to 0, right? Whenever you have a horizontal line, its gradient is 0 in every situation. यहाँ की situation अगर हम discuss करें, तो हमारे पास change in velocity नहीं है. Constantly velocity 0 है, उसमें कोई change नहीं आ रहा. If change is equals to 0, 0 divided by any number is always equals to 0. इसलिए हमारे पास इस graph में acceleration is equals to 0. और situation हमारे पास क्या है कि body is at rest. Let's look at the second graph. यहाँ पर, let's say that this is 10 meters per second, and I have my graph over here. Nabiha, यहाँ पर velocity क्या है हमारी कार की?
It's
Okay.
10.
That is right. It is 10 because the y-axis is representing velocity, और हमारा it's the line is cutting the y-axis at 10. So the velocity is equals to 10 meters per second. So in this case, Haya, can you please tell me कि velocity हमारे पास constant है, तो is it, can I say that this is uniform velocity graph?
Yes, miss.
Yes. Whenever we have a straight line, that is uniform. And as the velocity stays constant throughout, this is a uniform velocity. So, यहाँ पर, what is the change in velocity equals to? Zen, can you please tell me कि यहाँ पर change in velocity क्या है? Velocity का में कोई change आ रहा है कि नहीं आ रहा?
Acceleration.
Velocity constantly 10 है, तो उसमें कोई change नहीं आ रहा है ना, तो change is equals to 0. Is that right, Hussein?
Yes, miss.
Okay. So this change is equals to 0. क्योंकि the graph clearly shows कि आपकी velocity constantly 10 meters per second है. So the change in velocity is equals to 0. Now, if the change is 0, and we know that acceleration is change in velocity divided by time. अगर हमारे पास change 0 है, any number divided by time will always be equals to 0. So in this straight line, the gradient is 0, hence the acceleration is also 0, and we proved it just over here. Now let's move on to this graph. अभी ऊपर discuss किया था कि whenever we'll have a graph passing through the origin and it's a straight line, तो उसका gradient will be constant, right? Velocity time graph का gradient Nabiha क्या represent करता? Acceleration. Velocity time graph का gradient represent करता है acceleration. Whenever you'll have a line passing through the origin and it's a straight line, gradient is constant. The gradient constant है, तो acceleration will also be constant. हमारे पास acceleration is a vector, है ना? तो vectors के हमारे पास magnitude के साथ साथ direction भी होती है. ये gradient तो हमें सिर्फ उसका magnitude बता रहा है. It's not telling us the direction. Direction पता करने के लिए we look at the shape of this line. If it goes up, that means it's positive or increasing. If it goes down, that means it's increasing. So if I drew a line over here, जहाँ से velocity मेरी decrease कर रही है linearly, it's uniformly decreasing. ठीक है? इस situation में हमारे पास acceleration is constant as well, because the gradient is constant. So I'll just write here, acceleration is equals to the gradient, which is constant. लेकिन इन दोनों graphs में फर्क क्या है? एक upward facing graph है and one is downward facing graph. One is going up and the other is going down. Downward को हम negative acceleration कहते हैं because it's decreasing acceleration, or we call it deceleration. So what we have learned here is जब हमारे पास horizontal line होती है उसका gradient हमेशा zero होता है. Horizontal line का gradient क्या होता है? हमेशा zero. अगर gradient zero है तो आपकी acceleration भी zero होगी. First two graphs में हमारे पास horizontal line है. Gradient is equals to zero. I'll just write it over here as well. Horizontal line का gradient is equals to zero. अगर gradient zero है तो हमारे पास acceleration will be zero. And what's the reason for that? Velocity time graph of gradient is equals to acceleration. So I'll just go from the top now. Velocity time graph of gradient is equals to acceleration. हमारे पास जब भी horizontal line होती है तो उसका gradient is equals to zero. अगर gradient zero है तो acceleration will automatically be zero because the gradient is equals to acceleration. लेकिन अगर हमारे पास straight line होती है that is passing through the origin, where there is a straight line that is in this downward facing direction, यहाँ पर इन दोनों cases में gradient हमारे पास constant है. अगर gradient constant है तो acceleration is also constant. ठीक है? लेकिन ये जो the graph that is going up is positive और जो facing the one that is facing down is negative. यहाँ पर accelerate कर रही है body, यानी कि इसकी velocity increase कर रही है, और यहाँ पर body decelerate कर रही है और it's slowing down. Does anyone have any confusion in these four graphs?
No, miss.
Zain, Husnain, आपको कोई confusion in graphs में?
No, miss.
Okay, great. Actually, now I'll ask you guys a few questions about the graphs that we did before we move on to the next few things. Haya, can you please tell me कि whenever we have a horizontal line, उसका gradient क्या होता है?
Zero.
That is right. And what does what velocity time graph का gradient हमें क्या बताता है?
Acceleration?
That is right. Velocity time graph का gradient acceleration बताता है. Zen, could you please tell me कि let me see. अगर हमारे पास एक straight line है that is passing through the origin, यानी कि zero को cut करती है, उस situation में हमारे पास gradient क्या होता है? Is it changing or is it constant?
Constant.
That is right. Husnain, can you please tell me कि अगर हमारे पास upward facing straight line है, तो वहाँ पर body accelerate हो रही होती है या decelerate?
Accelerate.
That is right. और अगर downward facing line हो?
Decelerate.
That is correct. Excellent job. So you guys have caught up with this concept. Now let's move on to the next thing about velocity time graphs. अभी हमने constant acceleration पढ़ी है और deceleration देखी है. Now let's look at changing acceleration and deceleration. So changing acceleration. ये चेंजिंग जो है इसके लिए हम वो टर्म यूज करते हैं नॉन यूनिफॉर्म. नॉन यूनिफॉर्म इज जस्ट अ टर्म फॉर चेंजिंग. जब कोई चीज चेंज हो रही है दैट इज नॉन यूनिफॉर्म. यू गाइस कैन रिमेंबर इट बाय अ सिंपल एग्जांपल कि जब आप लोग स्कूल में यूनिफॉर्म पहन के जाते हो वो सबके लिए सेम होता है, राइट? So uniform is simply something that is constant or same. That's the literal meaning of that thing. और अगर change हो रहा है कुछ तो वो non-uniform है. और non-uniform graphs हमारे पास हमेशा curves होते हैं, ठीक है? अब now you guys will tell me कि अगर मेरे पास upward facing curve है तो gradient increase होता है कि decrease? Nabiha, could you please tell me?
Increase.
That is correct. Zen, could you please tell me अगर gradient increase होता है तो acceleration यहाँ पर क्या होगी? Increase या decrease?
Increase.
That is correct. Abdullah, could you please tell me कि अगर downward facing curve है तो यहाँ पर gradient क्या हो रहा है? Increase होता है कि decrease?
Decrease.
That is right. Velocity time graph का gradient हमें क्या show करता है? Acceleration. अगर velocity time graph का gradient decrease हो रहा है तो acceleration क्या होती है? Increase या decrease?
Decrease.
That is right. आपको ये ग्राफ्स रीड करने आने चाहिए. क्वेश्चन में आपको वो ये ग्राफ्स ड्रॉ करके दे सकते हैं और मैंने जितना कुछ बताया ना ये सब कुछ टेस्ट किया जा सकता है. इनमें से कुछ भी वो आपको डिस्प्लेसमेंट टाइम ग्राफ इस तरह का देके पूछेंगे कि बॉडी किस सिचुएशन में इट्स एट रेस्ट, इस तरह का दे देंगे और पूछेंगे कि वेलोसिटी का क्या हो रहा है, यू विल से इट्स कांस्टेंट. आपको कर्व्स देंगे, यू विल से दैट इट्स नॉन यूनिफॉर्म वेलोसिटी, इंक्रीज हो रही है यहाँ पर डिक्रीज हो रही है. डिफरेंट इंस्टेंसेस पर वेलोसिटी फाइंड करने के लिए कह सकते हैं. जब आपको एक इंस्टेंट पर वेलोसिटी कर्व से फाइंड करनी हो यू विल ड्रॉ अ टेंजेंट एज आई स्टेटेड अर्लियर और इस टेंजेंट का ग्रेडियंट फाइंड करते हैं. क्योंकि हम कर्व्स का ग्रेडियंट आपके लेवल पर फाइंड नहीं कर सकते. We only know one formula, that is y2 minus y1 divided by x2 minus x1, and that is applicable on only straight lines. ठीक है, तो कर्व्स पे आपने टेंजेंट ड्रॉ करना है और इस टेंजेंट का ग्रेडियंट निकाल लेना है to find out your instantaneous velocity. अगर हमारे पास velocity time graphs है, straight line हमारे पास straight horizontal line is equals to 0 acceleration. A line passing through origin, a linear graph shows constant acceleration. अगर downward facing linear graph है, that is deceleration. अगर हमारे पास curves हैं, upward facing curve is increasing acceleration, decreasing acceleration. We have learned to interpret and plot displacement time graph and velocity time graph. And we've also learned how to deduce information about motion from the shape of displacement and velocity time graph. Now, there's one more important thing about this chapter, Joke. Trust me, it's tested a lot. And when I say a lot, I really mean it. You guys should know what the area under a velocity time graph represent. Okay, let's say we have this line here. This is a graph. यहाँ पर I need to figure out the area under this graph, and then I'll show you guys what that represents. कैसे find करेंगे? I will draw an imaginary line here and complete my rectangle. ठीक है? अब इस rectangle का area, that is the area under this line or the area under the graph. अच्छा, can someone tell me कि rectangle की area का क्या formula होता है?
Length multiplied by breadth.
That is right. Length into breadth or length into width. यहाँ पर हमारे पास length किसके equal है? Time के, right? और velocity किसके equal है हमारे पास? Width के. So this is length and this is the width. If I multiply the length with the width or the breadth, is it the same as saying कि हम time को velocity से multiply कर रहे हैं? right guys?
Yes, miss.
और time into velocity, अगर हम अपना velocity का formula arrange करें, velocity is equals to displacement divided by time. If I take this time to the other side of the equation and multiply it, which is v into t, that is equal to displacement. So हमारे पास velocity into time is equals to displacement. So that proves that the area under the velocity time graph represents displacement. Does anyone have any confusion in this concept?
No, miss.
Okay. Haya, is that clear to you? Oh, she has left. Nabiha, is it clear to you?
Yes, miss.
Okay. Abdullah, can you please tell me the area under the velocity time graph क्या represent करता है?
Acceleration.
Abdullah, are you kidding me?
Speed.
Are you done with the guesses?
What is
Okay,
it?
tell me, are you okay? What are you doing? Are you using Instagram or watching TV or what?
Instagram.
Okay. Now you guys should know important shapes. एक तो हमारे पास rectangle आ गई है. Now you guys will be given graphs that will have different shapes. So जब आपके पास horizontal line है तो you will form a rectangle. Let's say you have this graph right here. इस ग्राफ का अगर मैंने displacement find करनी है, graph find करना है, तो what will I do? The first thing is that I'll just extend this down, and this will be my area under this graph. So, Nabiha, can you please tell me कि ये कौन सी shape बन रही है?
This is a triangle?
That is correct. This is a triangle, and to explain it more, it's a right-angled triangle.
Yeah.
So, आपको right-angled triangle का भी formula आना चाहिए. Zen, do you remember the
Okay,
formula? Right.
Sorry.
It's okay. No, it's all right. Zen, आपको right-angled formula triangle का formula याद है?
Yes.
Can you please tell me?
1 divided by 2 length multiplied by width.
That is correct. Right-angled triangle का formula होता है area का 1/2 base into height, or simply 1/2 BH. Base into height. And this is the base. And you don't have to take the slant height. Slant height नहीं लेनी आपने, y-axis वाली height लेनी है. This is the height. Right here. So 1/2 base into height is equals to the formula of your right-angled triangle. Now, we have a shape called a trapezium. Let's say हमारे पास ऐसा velocity time graph आता है, or it does get complicated. When you get a graph like this and you see that the enclosed figure in this situation is a trapezium. Trapezium क्या होता है? आपके पास दो parallel lines होती है. उनकी जो length है वो vary कर सकती है, and they're joined. इस तरह. ये आपका trapezium है. Now, the formula for trapezium is 1/2 sum of the parallel lines A plus B. In parallel lines को हम A और B label कर लेते हैं, multiplied by the distance between these parallel lines, which we call the height. ठीक है? ये हमारे पास height है. Parallel lines के दरमियान का distance is the height. So this is the formula for the area of trapezium. Does anyone have any confusion in this formula?
No, miss.
Okay. आपको ये तीनों formula याद होने चाहिए. Rectangle के लिए length into width. ठीक है? And then you guys will be perfectly fine with any question related to the area under velocity time graphs. पता है क्या करते हैं? स्कूल में हमें ऐसे सिखा रहे होते हैं कि आप इसको break down करो figure को एक triangle में इस तरह 3 shapes में divide कर देते हैं. That's what we typically do. एक ये rectangle triangle हो गया, एक ये triangle हो गया, और एक ये rectangle हो गया. इसको क्या कहते हैं फिर? एरिया 1 मार्क कर लेते हैं, एरिया 2 मार्क कर लेते हैं, और एरिया 3. इन तीनों का अलग अलग निकाल के ऐड करते हैं. एंड दैट इज टू मच वर्क फॉर 3 मार्क्स, राइट? इफ यू डायरेक्टली अप्लाई दिस फॉर्मूला तो आप आसानी से अपना आंसर निकाल लेते हो और आपका टाइम वेस्ट नहीं होता. दैट्स व्हाई इट्स रियली गुड टू मेमोराइज दिस फॉर्मूला. ऑलराइट. अच्छा, अब से कि एक टेनिस बॉल है and a person throws it up. आपने इमेजिन करना है अपने रियल लाइफ सिचुएशन में, क्योंकि वेलोसिटी और स्पीड टाइम ग्राफ्स को अगर आपने डिफरेंशिएट करना सीखना है ना, तो इट इन्वॉल्व्स अ लॉट ऑफ डायरेक्शन एंड स्टफ लाइक दैट. और अगर आप अपनी रियल लाइफ सिनेरियो को इमेजिन करोगे तो इट विल बी अ लॉट, इट विल बी जस्ट लाइक अ पीस ऑफ केक फॉर यू गाइस. लेट्स से दैट देयर इज अ टेनिस बॉल एंड अ पर्सन थ्रोज इट अप. जब आप बॉल को ऊपर फेंकते हो तो जब वो अपनी मैक्सिमम हाइट पर पहुंचता है तो it temporarily stops and then it comes down, right? Comes down. ये इसकी maximum height थी और यहाँ पर इसकी velocity 0 होती है. It temporarily comes to a stop, right? अगर इसकी velocity 0 नहीं होगी तो ऊपर जाता जाएगा ना. अगर इसने नीचे आना है तो इसकी velocity यहाँ पर थोड़ी सी मतलब 0 हो जाएगी, फिर ये वापस नीचे आ जाएगा. Now, if I was to represent this journey in a speed time graph, it will look something like this. यही जर्नी अगर मैंने वेलोसिटी टाइम ग्राफ में रिप्रेजेंट करनी होती तो ये ऐसी दिखती. अब ये दोनों डिफरेंट क्यों है? बिकॉज स्पीड इज अ स्केलर एंड वेलोसिटी इज अ वेक्टर. इस ग्राफ में यू सी कि जैसे ये बॉल ऊपर जाता है तो इसकी स्पीड डिक्रीज होती है, राइट? ऊपर जाता है तो इसकी स्पीड डिक्रीज हो जाती है आहिस्ता आहिस्ता. फिर ये अपनी मैक्सिमम हाइट पर इसकी स्पीड 0 होती है. फिर जब ये नीचे आते हैं तो इसकी स्पीड इंक्रीज होती है. Increase. Is this graph clear to you guys? Does that make sense?
Yes.
Zain, Hussein, is it all right?
Yes, miss.
Okay. अब यहाँ पे velocity line graph है आपके पास. ये section 0 से ऊपर वाला positive velocity represent कर रहा है और 0 से नीचे वाला negative velocity represent कर रहा है. ये पॉजिटिव और नेगेटिव असल में हमारे पास डायरेक्शन है इस वेलोसिटी की. जब ये बॉल ऊपर जाता है we take the upward as positive and downward as negative. ठीक है? जब ये बॉल when the ball is moving upwards, इसकी वेलोसिटी वैसे तो डिक्रीज कर रही है और फिर जब अपनी मैक्सिमम हाइट पर आता है तो इसकी वेलोसिटी इज 0. फिर ये बॉल डाउनवर्ड मूव करना स्टार्ट करते हैं तो इसकी वेलोसिटी को हम नेगेटिव ले लेते हैं. ठीक है? और यहाँ नेगेटिव में इंक्रीज 1 2 3 4. ये नंबर हमें वेलोसिटी मैग्नीट्यूड बताएगा और इसका नेगेटिव क्वाड्रेंट में होना यानी नेगेटिव ब्लॉक में होना हमें बताता है कि इसकी डायरेक्शन ऑपोजिट होगी. अब ये नीचे की तरफ आ रहा है. इज दिस क्लियर गाइस?
Yes, miss.
Okay, so if I wanted to find the area under these two graphs, speed time graph का area हमें बताएगा distance. ठीक है? क्योंकि speed into time is distance. ठीक है? Speed time graph का area under this graph is equals to distance. Area under the velocity time graph is equals to, can someone tell me? Velocity into time क्या होता है?
Displacement.
That is correct, displacement. यहाँ पर हम एक बहुत इंपॉर्टेंट कॉन्सेप्ट सीखने लगे हैं, इसलिए आपने गौर से सुनना है. अब इधर का मैं एरिया अंडर ग्राफ फाइंड करूंगी तो मेरे पास एक ये ट्राइंगल है और एक मेरे पास, मैं इसको एक्सटेंड कर लेती हूँ, एक ये ट्राइंगल है. I can label this as my area number 1. This is area number 1 and this is area number 2. मैं इन दोनों के separately areas find करके add करूंगी तो मेरे पास distance आ जाएगा, right? So area 1 plus area 2 is equals to my distance. On the other hand, let's look at this. This is my area 1. And if I extend this, this is my area number 2. Okay? This is area 2. Now, you guys see area 1 plus area 2 will be my displacement. Area 1 plus area 2 will be the displacement. Area 1 मेरे पास positive है और area 2 is negative. So area 1 is positive plus area 2 is negative. Positive, negative, plus, minus. If I, hold on, let me just do it. Area 1 is positive, positive 1, and area 2 is negative 1. And 1 plus minus, like there is a bracket and these two signs are being multiplied, so plus minus will be minus. 1 minus 1 is equals to 0. So you guys see, जब हमारा ball, when we threw it upward, it went up and it came back to its original position in the person's hand. Displacement हमारे पास तब 0 होती है. ठीक है? So the point that you guys need to remember here is that when a moving body returns to its original position, तो displacement क्या होती है? 0. This is a very, very important and very much tested concept as well. जब भी आपकी moving body अपनी original position पे आ जाए तो displacement 0 होती है. Let's say कि ये point A था और ये point B है. The car, a person moves from point A to point B like this. ठीक है? And then the person moves back to point A, जो मर्जी वो अपना route ले ले. क्योंकि वो अपनी original position पर वापस आ गया, उसकी displacement will be 0. यहाँ पर भी we threw the ball up and it came down. ये उसी अपनी position पर वापस आ गया. इसलिए displacement is 0. Is it clear, guys?
Yes, miss.
Yes.
Okay.